Okay, so let's talk about this idea called closure. Now, closure is something I've been taking some summer classes in math, and this is something we still talk about. And it's something I didn't really understand when I was younger. So hopefully a little introduction will help. If you think it's a little tricky, that's okay. We won't be doing a ton with it this year, but it's a nice little introduction to something that's kind of a big idea. Okay, so when something is said closed, we'll say it's closed under addition or closed under some sort of operation. Basically, what that means is if you take like the real numbers, okay, so that's all the numbers you know. If you take a real number under addition and you add it to another real number, you're gonna get a real number. Any real number that you can think of, pi is a real number. I can add it to 4, which is another real number, and I do get a number. It's just called 4 plus pi. Um, that's as simple as it gets. But can I graph it on the number line? Yes, because if I take something on the number line and I add to it, all I'm doing is moving it right or left, and it's still going to be graphable. So it's closed under addition. Now, what other sets are closed under addition? So let's talk about the natural numbers. The natural numbers are your 1, 2, 3, 4s. If I add any of those numbers, am I going to get another number that is natural? Well, let's think about it. 1 plus 4, 1 plus 3. All of those will still give me natural numbers. So the natural numbers are closed under addition. How about the whole numbers? Are they closed under addition? Well, what do we have here? We have 0, 1, 2, 3, 4. If I add any of those numbers, will I get another number such as that? And the answer is yes. The whole numbers are closed under addition. How about the what's next? Already did natural. Integers. Integers are -3, -2, -1, 0, 1, 2, 3. Now, a lot of times when we're checking for closure, it's nice to like find little special cases. Like 0 is always nice to look at. If I take 0 plus any of these numbers, am I going to get one of these numbers? Yes. Opposites are nice to look at. Is -3 plus 3 still give me an integer? Yeah, it gives me 0. So the integers are also closed under addition. And then what do we have? How about after integers, what do we have? Rational. Are the rational numbers closed under addition? Rational numbers is kind of tricky. And I'm going to kind of show you what that looks like here on this next slide. Okay, showing that they're closed under addition. Now, a rational number is an integer over an integer, and it can be written as a ratio. So let's say that they're all different numbers, like A is 1. Let's say that A, B, C, and D are all integers, and they can't be 0 if they're B or D, because then it wouldn't exist, so that doesn't count, okay? So let's pretend that's the case. This would be a rational number, and this is a rational number. I'm going to add them together and see what I get. Well, when I add fractions or rational numbers, I need to get a common denominator. So my common denominator is going to be BD. So to get this to be BD, I'm going to have to take top and bottom times 1, and I'm going to get AD over BD. And I'll need to take this guy times B over B, and that'll be CB over BD. When I add those together, I get A times D plus C times B over BD. Now, what does this mean? These are all integers, and they can't be 0. We said that because it would give us a problem. But if I multiply two integers together, and then I add to it two integers, and I'm going to get a integer, right? And down below, if I take two integers times each other, I'm still getting an integer. So once again, I get another rational number. So they are closed under addition because this guy is rational. And that is tricky, and I'm okay if you don't completely understand that. I'm not going to ask you to do it, but that's the type of thing we're looking at. Now, how about what's the last thing we didn't do? Irrational. Irrational, Are they closed under addition? So you're talking about your specials, your square root of 2's, and your pi's, and these numbers that never end. Well, when you look at those specials, what happens if I take a pi plus a negative pi? What do I get? I get 0. 0 is not, it's not irrational. 0 is a whole number. It's an integer. It's a rational number, 0 over 1. So it's not irrational. It's actually rational. So it is not closed. So what we say is the irrational numbers are not closed under addition. Okay, this closure property, like I said, it's a big idea. If you are understanding it, you're probably ahead of the game. So no panicking about that. Okay, so now let's talk about the whole numbers. What operations are they closed under? Here's my whole numbers. Are they closed under addition? We said yes. When I add any of these numbers, I get one of these numbers. How about subtraction? Well, what is 0 minus 4? That's negative 4. Is negative 4 one of these numbers? And the answer is no, so it is not closed under subtraction. How about multiplication? If I multiply 0 times 4, I get 0. That's one of the numbers. 1 times 4, I get 4, one of the numbers. It will be closed under multiplication. And how about division? Well, 0 over 4 is good. How about 1 over 4? Is 1 over 4 one of those numbers? No, that is just a rational number. It is not closed under division. So that's an introduction to this idea called closure. And now we're going to talk about some other properties. The associative property, it's like who you associate, who you group with. Well, we don't group with anybody right now because of COVID. But basically, what they're saying for the associative property here is if you take 7 plus 8 plus 3, it's the same thing as if you change the order. This is commutative. I don't know where associative went. I wonder if I deleted it by accident. This one's commutative. Commutative changed the order. It goes back and forth. Associative, I'm going to see if it's on the next slide. I wonder if I accidentally, it looks like I forgot it. Associative would be this. 7 plus 8 plus 3. If I associate these two first, that's going to give me the same thing as if I take 7 plus 8 plus 3 and associate these two first, because 15 plus 3 is the same thing as 7 plus 11. Okay, so associative is who you associate with, always about groups and grouping symbols. The same thing is true with multiplication. 7 times 2 times 3. Okay, so if you take 7 times 2 first, then times 3, it's the same thing as if you take 7 times 2 times 3. 7 times 6 is 42, and 14 times 3 is 42. That's associative, who you group with. Commutative is the back and forth nature. Changing the order is okay. So what they took here is they took A plus B plus C, if that's A and that's B plus C, and what did it equal? It ended up equaling A plus C plus B, because the A's were still in that part, and then they just changed the order of those two parts. Or you could say A plus B is the same thing as B plus A. Order doesn't matter with addition. Same thing is true with multiplication. You could take A times B, and you'll get the same thing as B times A. Looking forward to the identity property. Identity property has this idea called an identity element. And there's identity property of addition and of multiplication. There is a special number, and we use it sometimes when we're checking for closure and stuff, that gives you what you started with. And the identity element of addition is 0. If you take A plus 0, you get A. The same thing is true with multiplication. The identity element of multiplication is 1. If I take A times 1, I still get A. And that's what allowed me to take that A plus B. What did I do? I took it times D over D earlier or something. Because this is 1. I did not change the value of the problem by multiplying by 1. So if you can find a fancy version of what 1 looks like, you can use it to help you solve math problems. Okay, inverse property. Inverse property, there's also something called the additive inverse. It's something that undoes something. And with addition, it's the opposite. So if you take A plus negative A, you will get 0. For multiplication, you take the reciprocal. If I take A times 1 over A, I get that identity element, which is 1 for multiplication and 0 for addition. Okay, distributed property is a classic. Everyone is really good at this. And I love the distributed property because I have gotten better since raising my own kids because we never did distributed property with multiplication like you guys did in elementary school. We did it like this. We draw our arrows, A times B and A times C. And you just memorized it. You would just draw those arrows. But what I see some of you guys doing isn't when you take 7 times 37 in your head, I used to do long multiplication and try to do this in my head, 21 to 2 to 3 to 4 to 5, and I'd be like 259. What you guys will do is take 7 times 30 plus 7, and you will take 210 plus 49, which is easier to manage in your head than what I did. So that's using distributive property to help you solve basic computations. You can also use it with algebraic expressions by multiplying 3 times x plus 12. We'll use that a lot this year as well. And then the last thing here is talking about taking words to symbols. Kids struggle with this. It's on the SAT a lot. Subtraction and stuff is a lot harder. But if they say 3 less than a number, everyone knows it's subtracting, but they forget which one to start with. 3 less than a number means you started with the number and then you lessed it by 3, which means you subtracted 3. The quotient, kids know it means divide, but you're going to take 2 times the number, which is 2n, and 4, and it's going to be 6. So the quotient, if you divide 2n by 4, you're going to get 6. So 2n divided by 4 is going to give you 6. Is means equals. And now this time they're giving you a word problem, and they're talking about Tyrone. He bought a calculator and 2 packs of batteries for $42. And frequently means plus. So if you take 2 batteries plus a calculator, or a calculator as a variable plus 2 batteries, the total amount he spent was $42. Okay, so we're going to get more into that too. This was just an introduction, a lot of vocab. That idea of closure is tough. Don't beat yourself over that yet. I've never started teaching it this early in the year, and I kind of hate it because I don't think you guys will be very good at asking questions yet until we get to know each other better. But it's a pretty big math idea. So if you did grasp some of that, that's awesome. And if you have more questions about it, that's okay too. All right, that's it for the first lesson.